Exercise 171, this is starting on page 46. We're going to keep it a little bit light for this last session. I mean, we're going to go through the exercise, but a lot of this we've already covered in the other breakline sessions at the butt end of those where we kind of go over the exports. So we're going to rehash some of that and then do some new things like a lot of times you want you've got this ortho, this really high resolution that you've created that is a very large size. So one of the things we're going to go over today that we haven't covered so far in this conference is how do we make that more manageable? How do we reduce that to a size that's usable in some of the more legacy or less capable CAD packages? And then also at the very end, we'll go over LandXML exports. So I think that'll be useful to a lot of people. And like I said, we open up LP360. Let's click on the Add Files dialog here at the top. Click on the LAS tab here in the bottom, or I'm sorry, the top left. Click the plus button and go ahead and add those LAS files. Again, they're going to be not LAS files, but LAZ files, compressed LAS files, and we'll select those. It's this little option here in the bottom right, switch that to LAZ, select the files, and click Open. Just regurgitating what I said the last couple of days. You've got some advanced options here in the import dialog for looking the coordinate system, the file type, things like that. And then just choose the default options. You can just set this to read only. All the classification we need has already been done. We're just going over doing the export based on already processed project. Of course, the classification is not perfect in this data set, but we're just going over the concepts here. So you can just open up read only. That's fine. And I'm going to let it do the LP-LAS pyramiding and click OK. This can take just a minute. If I've kind of going a little bit faster in some of this, so if I lost anybody, just let me know. Just go ahead and open those up. So we'll just give this a second. It was working okay. Right, so should almost be done here. And then we'll add a couple more files. I forgot to add a couple files. That's fine. We'll do that. This is good to get the practice. You see in the bottom left, when you add those, it gives you an update of what's going on with the, if you don't see anything yet, if LP360 seems like it's kind of frozen up, if you look in the bottom left, a lot of times there's an update. Right now it's pyramiding the files. There's the data loaded in. Let's click on that Add Files dialog again at the top. And this time let's click on the Raster tab. Click the little green cross, little plus button, and select ortho. Just select the bigger ortho. It's just called ortho.tiff in the ortho folder from the files that you've extracted. Click open. Same kind of thing if we scroll to the right. Eventually, if the ortho does have WKT, well-known text information, you can see the coordinate system and some other attributes of the ortho. Click on the feature tab to the right of the raster tab at the top. And let's just add all the features we were messing with yesterday. So this is curb, drainage, wall. We can go and add all those at the same time. And it's going to put those features on all separate layers when we do the import. So, yep, we should be good to go here. I'm going to click OK. So everything should be in there. And notice how I really didn't cover this the last couple of days, but if you use LP360, and this is like kind of we're looking down in the table of contents, looking at the different layers, the top layers like looking down on a sandwich, and as we peel back the layers, there's different layers of that sandwich. So you can left click and hold and any layer, and you can adjust its position in that sandwich, so to speak. So I'm going to move the raster layer on top of the LAS. and I can move it back down. So I'm just letting you know you can play with that. One other thing, kind of an Easter egg that a lot of people don't know about. Right click. You can follow along with me if you want, but right click on the LAS layer, go to transparency. There's an option for transparency, and we can actually adjust the transparency of the LAS with the ortho. So it really doesn't necessarily help us with this exercise we're doing now, but I just want to make you guys aware of that. It's just kind of a neat tool for if you're doing some classification, maybe some conflation, want to keep track of features. It's handy to keep track of where the LAS data is with the ortho and maybe even a base map. So I'm going to go ahead and click OK here. Let's go ahead and add a WMS layer. So I'm going to go ahead and do that at the top. Click Google Hybrid. So the data is popping in just fine. And let's save the project. So I'm going to go to, in the top left, I'm going to click Save Project. Just like we talked about yesterday, if I click on this little ellipse on the right, it's just going to automatically bring me to the spot where my last export came from. Maybe I want to put it up a couple levels from where I did it, from where the original data came from. So I'll go ahead and put this in the folder where my initial downloaded data is located. And then I'll give it a project name, like in the exercise, step 7 on page 46, I say CAD exports, but you can call it whatever you want. And then you can see the spatial reference system's already loaded because it grabbed that from the LAS data when we imported that. I'm going to click Save Project. It's just asking me, do I want to create that folder and that file and that location? And I say yes. All right, so the first thing we're going to do, and that we've done this the last couple of days, is just export a DEM with breakline enforcement. So let's just glance at the data real quick and make sure it looks okay. So I'm going to go ahead and at the top here, since this is a DEM that I'm producing, we want to look at how the surface looks. So I'll click on the option to the right of the legend display for changing from point display to 10 surface, and some different options here. Click 10 surface. And then I'm going to switch the filter to ground system. So we'll just look and see how the classification has been done. So we can just verify, okay, is this look okay before we do the export? And may do something as simple as go to the map view at the top, click on draw 3D view here, and then just look at our different breakline areas. Just make sure, okay, hey, is this looking like we want it to look like? Remember yesterday when we were doing breaklines and the day before, if I do a kind of an Easter egg here, do a control left click on the breakline button, we can go ahead and enforce breaklines. So I'm going to go ahead and turn all of them on. I'll turn on the fly topology on today as well. Modify classes, we talked about this. The classification is already done. It's class 20 ignore ground. Click OK. And then go ahead and turn that breakline on. Let's just see what it looks like. Of course, you have to tend the data to see what the result is. And then I'm holding down the left mouse button, moving it forwards and backwards. I can zoom in and out. Hold the right mouse button in the 3D view. I can rotate. And then both mouse buttons at the same time in the 3D view, I can pan. So I'm just glancing just to see, okay, does this breakline look like I want it to look before I do this export? I can even turn off the LAS data by clicking this legend and just make sure there's no gross errors in that shapefile we produced. And so we can do that in the other 2 locations as well. I'm just going to do that real quick. I'm going to go and turn the profile view off. And then I'll zoom into our wall over here at the bottom, do the same thing. Just doing a little bit of just a sanity check here, just a little bit of a analysis to make sure that before I spend time producing my DEM, DTM, that the data isn't looking off, and just making sure the breakline's enforced the way we want. Let's just look at that drainage stitch one more time. Just make sure there's no major issues. Just turn the breakline on and off. It looks okay to me. Of course, I haven't done this yet, but you can switch from elevation view to classification. and just make sure it's looking the way you want. Okay, so let's just go ahead and do an export of this data. Just the DEM with the break lines and force. So click on project in the top left. This is kind of like I said, we're just kind of rehashing what we've done the last couple of days, but I think it's good to get the practice in. Go to export type from export wizard up here, again in the project tab, and click surface on the dropdown. A lot of times, I mean, you know, we've been exporting GeoTIFFs the last couple of days, but there's a lot of other options here. The reason we do GeoTIFF typically is, I mean, it's most people want that format just because that's what they need it to be in. But in a second here, we'll do the same thing we've done the last couple of days again, where we do once we make the DEM, if it's in a GeoTIFF format, we can use the DEM-to-LAS function, so we can make a LAS layer based on that gridded DEM, and we'll have a gridded LAS data set. So that's another reason why we picked that option. As you see, cell edge length, let's make that pretty small. Let's actually go even a little bit smaller than what I list in step 2 on page 47. Let's do 20 centimeters instead of, I think I had you in the exercises set to a third of a meter, but let's do 20 centimeters. The data set's in meters here. Input points filter in the top right. Click on that and select ground system. Go ahead and click OK. And let's turn our break line enforcement on. All the break lines. Modify classes, same class 20.
What is the out areas option?
The out areas option. So let's, that's a good question. So you don't have to follow along. I'll just go ahead and make a quick out area just to show you what it looks like. So, let's see. Think of it like, basically you want there to be a void in your data. You know, you don't want that to be represented in the data set or the DEM. It'll basically just leave that out. So, just trying to think of a good example. I mean, a lot of times out areas will be like on the edge of your project, or, you know, it could be, maybe you want to leave the water body out. So, basically, typically out areas are polygons that you're leaving out, and it wouldn't be like points or like when we're using break lines in this scenario, it's you know, polylines, and out areas have to do with you know, how you digitize the polygon. So an out area could be as simple as you draw a boundary and you draw it counterclockwise, and you're saying that's the out area, so it's excluding everything outside of that polygon, that kind of thing. So let me go back to the export wizard. Okay, so let me set this again. Just let me know if I'm losing anybody. Well, this is a pretty straightforward, easy session today, so hopefully I'm not being too spastic here, doing the settings to where you can't keep up. Input points filter, we'll pick ground again. Okay, I think this looks good. Export type GeoTIFF, next. And we'll just do basic extend. I think that's what I call for in the exercise document. I think that makes sense. But of course, you have other options here for setting how, what area you're interested in to run this on. So I'm going to click next. Go ahead and set an output location. Just clicking this ellipse up here. And let's choose, I'll just call this DEM. It's the file name, and save, and then finish. This should look a lot like the export we did yesterday. I think we used a lot sparser setting for the pixel size for the DEM we produced. But this shouldn't take too long. Just give this a minute. We're doing a little bit more high quality just so we can see how the break lines are influencing the DEM a little bit better. So this will probably just take a minute. I may even cancel mine because this is taking a while. Is everyone's running? Okay. Shouldn't take too long. I did 1/3 of a meter last night, and it didn't take long at all. This is taking quite a bit longer. Just wait for this. Is everyone's running? What's the time looking like on yours? Yours what?
I'm not up here.
Oh, okay. Just give it another minute or two, and if it's taking too long, then we can always hit cancel and just use a lot sparser just so you can see the concept. Well, it's sparser setting. They may choke through there. As you notice, the estimated time, it's a very rough estimate. You can see it just went down 7 seconds and a lot less than 7 seconds. So just give it a minute. So while this is running, I'm going to hit cancel. Let's see. One thing I have not showed you guys, just I was trying to keep it simple and quick. I'm going to run this again. Instead of just running it straight, I'm going to submit it to the job manager, and we can track it there. You guys keep yours going like it is. And then in the top left up here, you see this little flag and looks like a little dialogue button. We can keep track of it in there, the export, and it tells us if I scroll to the right, it'll tell us how long it's been running for, so duration. So I know it's going to take a few minutes to run.
Is they using the same amount of computational resources and job manager?
Yep. Yep, it is. So I may, while that's running, I could even start another export, go ahead and queue that up. So the next export is to make a, let's see. I think I had set to, I just mentioned that you can make a ASCII XYZ as well, and we reviewed that yesterday. So let me just talk about that for a moment. You can choose a ASCII raster here, or and this would have to be at the endpoint cloud, of course. Go to points up here at the top. Choose export format ASCII XYZ, and you've got some additional options there. But you would need to do that after you've done some thinning of the data. Just let me know whenever everyone's finishes. You got about 5 minutes left. How long is it?
No, I'm in it.
In about 5 minutes. Go. Wait on it. Let me just check my job manager. Yeah. Let's do this, guys. I just don't want you guys just twiddling your thumbs. So I can do the same thing. What you can do in your dialogue, you can cancel. So I'm going to cancel job. So that'll take care of that. And I can even delete, get rid of it, take it out of my list. I wanted to. So if you want to go to your export wizard, it's still running, hit cancel, and let's change the cell length to 1 meter just to save time here. Do that real quick. And then just do the same export. And if you want to, you can submit it to Job Manager like I have this time, so you can keep track. Should go much, much, much faster. And it'll give you a progress as well. A little progress percentage. Is it running faster? You switch it to a meter? How long does it say? It's 6 minutes, okay. Gosh. Is everyone running in the Job Manager now? Did you try that? Okay. Well, let's do some more muscle memory here. Let's hit cancel again. Say yes. And you should see it take a second. Just give it a moment and it should say job canceled. Now if you want to delete that job you can, but you don't have to. Let's do this one more time, but this time let's just do a subset. So like we did yesterday, draw window and map. Let's do that. So go back to export wizard. This just went a lot faster last night. I'm sorry guys, when I was practicing at home with this. We'll do a 1 meter cell edge length to save us time. And in step 2, use draw window and map. Click on the draw tool button. I'm going to left click and hold. I'm just going to draw it over our little wall feature here. Hit next. And then I'll just run this one more time. And it should go much, much faster. There we go. Of course, you can always do the more detailed DEM or detailed export. You just have to wait, obviously, depending on your machine resources. Okay. Okay, so if you're doing this in the Job Manager, is everybody doing this in the Job Manager? Just let me know when yours is done. Is yours done as well? Okay. Just hit complete job after that. Say yes, and you should see it added to the map. I'm going to close Job Manager, and it is. Of course, it's probably a good bit sparser than it needs to be just to show that break line, but you can kind of see where the break line has been enforced. And so let's go ahead and do the next section here, DEM-to-LAS, is on page 48. So click on the Add Files dialog at the top. Click on DEM-to-LAS. Click that plus button. And just go ahead and navigate to that DEM you produced. Click Open. One of the things that I like to do, usually we're making this based on ground only, so destination class, it's going to put all the the points we're creating in a single class. So if you don't choose a class, it's just going to put it in class 0, created never classified. I'm going to go and select ground because I know that that's where the data originated from, and click OK. And it's going to create points at the, I'm going to zoom in a little bit, go a little bit slower than I have been the last couple of days. See, it's creating a point at the edge. I don't know if you can see this, but it's, second, make the points bigger. See, it's creating a point at the edge of each, at the corner of each pixel. It's creating an elevation point, a LAS point.
Averages of the surrounding port cells.
Yes, it has to be. Yep, that's correct. Yep. Actually, I don't think so. I think it's the top left. So whatever the top left value is, that's what it is for that pixel. So this elevation value comes from this one. The elevation value for this comes from this pixel, so on and so on. So it should be from the top left of each pixel, if I'm not mistaken. Yep, I think that makes. Let's see. Yeah, because look, this goes right along with what I just said. So if you look at the pixels in the bottom, there's no points at the very bottom. This is because it's come from that top left value. Yep. Took me a second to remember that. Let's go ahead and tend the data that we just we did DEM to LAS. Let's go and tend the data, and we can just this would be where you just QC and seeing, hey, does that DEM look roughly like I want it to? But we can also do some extra things from that as well. And we did that the previous 2 days as well. So if we go to Export Wizard at the top, based on this, just set your active LAS layer to DEM to LAS. Based on this gridded LAS layer, we can make a ASCII XYZ export. A lot of people want that. A lot of people, clients ask, hey, I want to make an XYZ file based on my data, and I want it to be a thinned point cloud as well. And so this is a really good way to do that. Be surprised how many people ask for that. So input points filter, we don't have to change that from our previous export, set to ground, because when we created this file, we set the destination class to ground, so it should be good to go. I'll hit next. We'll just do basic extent this time. Extent of active LAS layer. We're not going to draw an area in the map view, and I'll set an export. I'll call this just XYZ. Click Save. Finish. As you notice, I selected Submit to Job Manager, so now it's going there. The real advantage to submitting to Job Manager versus how we've been doing it, the last couple sessions, is you can do other things while it's going. If you want to keep classifying, if you want to keep doing other things with your data, importing data, or anything else in LP360, you can keep doing that while it's running in Job Manager. Also, you can queue things up. So, if you needed to do multiple exports, say you were exporting one section here, and you knew you're going to needed to export another section in the same data set, you can just queue those up. So let's just pretend for a second this is still running in Job Manager. I could go to Export Wizard again and kick off something else, and it's just going to queue up in the Job Manager. So that can be helpful to you depending on the scenario. The one thing here is that typically when it says it's ready, it's completed, you do have to hit complete job in the top right just to finish up. And of course, when I do that, nothing's going to happen in the table of contents. Nothing's going to happen in my view because I did that XYZ export. So if I just want to just glance at that real quick, remember I showed you this little trick yesterday. I'm going to right click on a layer in the table of contents and then go to Open Location and Explorer, and it'll bring me right to my project data. And I'm just going to go up to level where I produced that. And then let's just, that's our XYZ file that we generated. I know some people are probably waiting on their DEM to export still. Is everybody caught up at this point? Okay. So one of the other things that is common when people are working in different CAD packages is just very limited in what rasters you can load and the size and the formatting and things like that. We typically make, if anybody's using Agisoft Metashape or Pix4D, typically when you make that big ortho, it's got to make it in the big TIFF format so it can handle the larger file sizes of the orthos. A lot of times CAD packages can't handle big TIFF format at all for a GeoTIFF image. It just won't load. Or if you are able to load an image, it's just achingly slow performance, and it's just basically unusable. So I'm gonna switch back to my regular LAS layer. I'm gonna turn off these DEM layers. So I'm gonna just I'm gonna left click and hold and move that raster layer to the top. So we're gonna basically reduce the quality. We've got this ortho that I've given you. It's in big TIFF format. It was produced using Agisoft Metashape. If I right click on it and go to Open Location Explorer, it's roughly a 400 megabyte file. Even something that small, some CAD packages completely struggle with something, even something that size. So one of the things I've given you for this exercise, go to Point Task at the top, go to PCT Manager here in the top left, and click Import here, the top, and then navigate to the PCT Groups folder from the exercise data, and then click on the 2025 UC CAD export group. Click Open. I'm going to go ahead and click on Favorites here at the top. Click on that export group, and you should see on the right side the PCTs that we've set aside for this exercise. After loading in that, let me know if anybody has any issues with that. After loading in that, click on Filter By in the top left. And as soon as we click on Group, it's going to warn us like, hey, the PCT you're currently on, it's not in the filtered list of tasks you're selecting, but that's okay. We don't care. It's just giving you a warning that, hey, you're switching from something you'd had up previously. So don't let it throw you. And then click on Ortho Convert. That's what we're going to be running, or Ortho Convert. Once you've selected that, click on Active PCT Settings. So one of the things we have in here, I was playing with this last night. Yours should be set to something like 60. We have the ability to basically perform some additional JPEG compression on the data to make the file size substantially smaller, but the quality is basically very similar to the initial file. And also we can update the pyramids. And then if you're bringing this into CAD software, you will uncheck the Create Big TIFF option. That's important. So we're basically converting from this big TIFF file to a file that's just regular TIFF format. Just keep in mind that if you have that unchecked, and if it's a really massive file, it may not be able to produce the file. There's a size limitation for just a regular TIFF file. So it has to be something that's reasonably sized. I mean, if you flew 10,000 acres and you have an ortho like that's 50 gigabytes in size, this method is probably not going to be good enough for you. So just keep that in mind. Notice we're leveraging a PCT task that's not explicitly necessarily made for this. This is our reproject raster PCT, but I'm using it. I'm not actually doing any kind of SRS conversion, spatial reference system conversion. I'm just using this to reduce the quality of the ortho. So select input raster. If yours is not already set to this, if yours is set to, we have to specify that. I think by default it's set to raster layer 2. So click on that ellipse and just select the correct raster layer that you have loaded in. Mine's raster 1. It should be for you as well. Okay, so that should all be set. And then output folder, I'm using the project path option. But if you click on this is our IO manager here. We have different options here, and basically all I've done, let me show you. You can click in this, the output folder path, and you can manipulate it however you want. And this is that project path option. So in the top right, you have the greater than, less than symbol. I'm going to click on that. And I'm basically saying I'm going to put it here. So I'm going to click project in the top left, click on settings on the right. I'm saying I want to put it, here based on the project path that's set for the project. Maybe I want to get a little bit more detailed in how I want this organized. So I could even put, make a new folder called ortho, I just call it ortho reduced. And then I could do a backslash and then set the file name as well. So we'll say, actually, no, you wouldn't be able to, for this specific option, you're just selecting a folder location. So maybe I'll have just a folder, ortho reduced folder set. I'm going to close this and also have it set to add to map. So let's say you actually did use this as a reprojection. When you do convert SRS, make sure that you have add to map unchecked. LP360 does not perform on the fly reprojection. So right now I'm in, let me go to my project on the right settings. Right now I'm in 93 2011 state plane Alabama East meters and ellipsoidal meters. Let's say I wanted to reproject that to US survey feet and then an orthometric height. If you did that using this tool, just make sure, again, you have it add to map unchecked. If you add it to map, the data is not going to look correct because we don't perform on the fly reprojections, and it's just going to appear like the data is off in some weird spot. So if you do that, save the project, create a new project, and import that reprojected file you made, and then it'll show up in the right spot. All right, so I'm going to uncheck convert SRS, and I'm going to click OK here. The settings look the way I want. Click on point task to the top and just run by active layer. That's fine. Click yes. And then it should be pretty quick. And I think yours is set to 60 by default, or the way I set it. Should go pretty quick. So it's making the initial ortho, and then the second part is pyramiding the file, generating overviews so we can zoom in and out and it doesn't behave in some kind of weird way. It's a little bit more fluid performance.
Does LP360 have any guidelines on recommended processing settings for Metashape or jury ortho?
Oh heck yeah, we've got a help document for that. So let me just go. That's a really good question. He just asked, do we have any recommendations for? Specifically, he's asking about the Agisoft ortho mapping option. I'm going to go ahead and click on support at the top. Go to knowledge base. Just click on knowledge base. Oop, I'm not connected to the internet. That would help. There we go. And let's type in Metashape. We'll say Agisoft. Metashape. Actually, the specific tool is Agisoft ortho mapping. There we go. How to use Agisoft ortho mapping, and then we go through, why we're using this, the licensing that's required, and we kind of do a little bit of a deep dive on settings. A little bit of in here, with basic settings, you can get a reasonably good ortho, and then we kind of go to, if you want the ortho to look a little bit cleaner for these certain types of features, there's a little bit of extra work you do. And then we go through, it's kind of, you do this initially, and if you want to take it a step further, you can do this. And buildings, trees, different things like that can look better if you do some of these additional options. On top of that, there's a settings file. Let me see. The top option up here. There's an additional, we also go into advanced settings here in these articles, but there's an additional MS config file if you want to get really elaborate with some of the additional settings that are available in Metashape and run them through LP360. This can help with the white balance. There's a lot of times people will fly a mission and the sun is on one side of the aircraft, and then when you're doing your flight line passes, then the sun ends up being on the other side of the camera, and then you see some uneven lighting. So this can, using these options, calibration, colors, white balance, some of these other options, advanced options, in the Metashape settings file, you can actually help with those kind of issues. So, yeah, just keep the questions coming if you have any. Okay, so I should have just made that raster file. Let me see where it ended up. Let me click on project here in the top left, add files. Let me see. There's my ortho reduce folder. I click open. I guess I'd had that add to map unchecked. So I'm going to right click on that raster layer 2 and go to open location explorer. Go to view here at the top, look at details, and we basically cut the size in half. We've basically cut the size in half by doing a changing the compression ratio to 60%. And let's just go ahead. I'm just going to use my mouse wheel and zoom in on the ortho. Let's turn these on and off. So you can see here's the original ortho. Let's zoom in on this little concentric circle. There's the original ortho. Here's the one at 60%. I mean, you basically almost can't even tell a difference. And we've basically cut the file size in half. And so you can go even a little bit further. So let's just go ahead and play with this while we're here, just so you can kind of see it's diminishing returns. Once you compress it to a certain level, it starts to really affect the data fidelity of it. And it's, depending on your application, it might be unusable. But let's say you're just wanting a kind of a zoomed out overview of the site, and you don't necessarily care about zooming in and look at the individual pixels. You can reduce it a good bit more. So let's go to point task at the top, click on active PCT settings again, and let's change it to something like 20. Let's do a good bit more. And we're still referencing our original raster layer. I'm going to change that to add to map this time. I've forgotten to set that. Let me know if I'm losing anybody. I'm kind of clicking around kind of fast. So I'm going to click OK. And let's just run that again and see what 20 does. Anytime we reduce that value, we're choosing to compress the file even more. So, of course, I think the default setting is set to 90, so it's not as compressed. Go ahead.
So y'all been playing to add the ECWs you said extra export options for that?
I thought I know we import that, but I don't. That's a good question. If you need those, can you? Have you put in a feature request for that already? Oh, okay. Let's move that to the top of the list. So, yeah. So let me. I'm gonna make a little note for that. Yeah, that's a good question. Yeah, I'm familiar with what you're talking about. Yeah, because we already have some import options there, but I don't think we can export anything at that. Yeah.
Yeah, use a third party right now. It'd be great.
Yep. That's a good question. Okay, so that raster layer produced, I moved that to. I just left clicked and held and moved that to the top of the sandwich, so to speak. And let's zoom in on that. See how the quality's been reduced. We can compare. So let me go to that concentric circle again. So, I mean, honestly, let's just click through. You can see it doesn't look quite as good. But I mean, if I'm making a manual accuracy measurement on this, I still have plenty of fidelity to do so. Let's look at a checkerboard real quick too, just to see what that looks like. See, if I wanted to measure the center of that, I'm still good to go. And let's right click on that raster layer 3, open location explorer. Let's see. Yeah, I've reduced it from basically more or less halved it again. So it's less than a quarter size of the initial data that we started with. That 400 megabyte file, I've reduced it to 70 megabytes and really kept a lot of the fidelity there. So I think for most users and most applications, this is going to be the go-to setting and workflow for reducing that the quality of the ortho import into your different CAD packages. The next part of this is tiling the ortho, and just full transparency. This is a really tricky operation, not just in our software, the other software packages. One of the main downsides of using a shapefile grid for doing this, typically you'll basically see a little pixel gap between the images. And when I presented this last year in the version of LP360 we had, I was able to produce this with no gaps. But just in this current build, I'm just seeing some kind of issue here. So you're going to see those gaps, but I'm still going to review the workflow with you guys, show how it works, and then at some point in the future that'll be resolved. So if you're actively needing that feature, just email support@guq.com and let me know, or let me know, and I'll make sure to let you know when that's resolved. But we're going to go through the workflow anyways. So we're on. This is an experimental build, so that's why we're having the issues. So let's look at the. I'm going to look at our active our PCTs that we have for this group. Click on Ortho Grid and in the drop-down option, and select. Let's click at the look at the active PCT settings, and we're saying we're going to make a grid that's basically 100 meters grid size, and we're going to make a full grid, and we're gonna click clip to the input LAS data, just so it kind of aligns with the LAS data. So if you got the ortho and the LAS data at the same time, you can kind of it'll better match the size of your ortho. And just go ahead and click by active layer at the top and click yes, and it's going to make that gridded file for us. So we're basically just making a shapefile grid based on our LAS data set, and we're going to use that to cut up our ortho. So this should just take a second. Just let me know if you'll have any questions as we go along. So part of the reason this is taking some time is because it's looking at the LAS data and trying to clip to that. If you had that unchecked, this would be pretty much instantaneous. So just keep that in mind. If you have a really large project and you already know, like I don't mind spending a little bit of time to kind of clip the tiling that's created on the edges of the project, then you can skip that step. And here's what I'm talking about. I'm going to click on the active PCT settings. You can say no clipping. You don't have to do this with me, but I'm just going to set this to basically make a new file just to show you the difference. I'm going to run that. It's instantaneous. So let's look at the difference. So this is and this becomes more important the more complex the shape, the more I don't know, the more irregular your LAS data is shaped. But basically doing that instantaneously, you can see we've got some tiles on the edge that don't really go with it. And when we chose that clip to input LAS data, it automatically took care of this for us. But let's say you wanted that to be instantaneous and you just wanted to manually remove those tiles. I'll show you how to do that real quick. Click on the Feature Edit tab at the top. Click on the Select arrow button in the top left. I'm just going to select those tiles. Hold down Control, and you can select another tile along with the tiles you've already selected. Delete those features. Save the edits, and we're right to where we were when we were waiting for it to basically determine where to make the tiling so it's actually overlapping the LAS and not just somewhere out in La La Land. So, all right, so you should have your grid. So we're going to go ahead and cut up the ortho based on this grid. One of the things I have in this exercise is basically telling you how to, we've created this grid. I'm just going to go ahead and zoom in. If you want to zoom along with me, just zoom in into where this grid meets the raster pixel. I'm just going to zoom way in. See how it's offset? This really has to be, you don't have to do this with me. I'm just going to show you. This really has to be lined up perfectly with the edges of the pixel so you don't get those, I guess I had surface Z mode on. That was a mistake. But just so you don't get those black pixel boundaries when you cut the ortho up. I've really kind of screwed myself having the Odyssey on, moving this. But just give me a second. There we go. I'm just going to hit undo here at the top. You don't really need to do that. I'm just showing you what happens. Even if I move this to the correct spot, and let's say I did this for all the tiles, it's still going to have those pixel edge boundaries because of the issue I already told you guys about. So we'll just run it as is this time, but just keep in mind that's going to be resolved at a later date. So click on point task at the top. Click on ortho tiling if you want to with me. Click on active PCT settings. And basically this is just running exactly the same thing we did before. So this is that convert raster PCT, but we're basically using that. We're going to run by feature layer, and then we can run on the individual tiles to kind of chop this ortho up. So go ahead and run by feature layer. Click OK. And then run on the ortho grid too. Click run. Now, as you'll see, it's going to make a whole bunch of raster files at the bottom. And I'll show you what we do with this. Is everybody running that wanted to? So it'll take just a minute. So it's just going through and it's generating a raster tile for each one of those spots that we've gridded. You can see it building in the table of contents right here. So one of the things I'm going to do is I'm going to re-import all these into a single layer after this is done. So it should have created 17 features. Click OK. And now I'm going to basically turn everything off. I'm going to select the layer at the top, hold down Shift, select all of them, all the layers, and then you can multi-select and then turn everything off. I'm going to left click to the side and just turn on one of those layers so you can see the individual tiles that it produced. And actually, like I was saying before, when you're zoomed out, let's say you just need an overall view of this, it looks okay. Notice how I have different color balancing throughout. I'm going to zoom in, and there is that 1 pixel gap. So depending on your application, you're just bringing this to CAD to help you out, this is still definitely usable. So if you got a massive ortho, you're bringing this into CAD just to use with helping you classify your data or for some other data point, still definitely usable. See how we have the difference in kind of color balance, white balance here between the different tiles. So I'm going to go ahead and select all the tiles in the TOC. And let's do this. Right click on one of the tiles, open location in Explorer. So now we see where that's located. In the active PCT settings for the output, I'd set it to the project path, the ortho folder, and a tiled folder, so it should be in there. But with that folder opened up, I'm just going to copy that location, just do a Control-C in the top taskbar, and then I'm just going to remove all these rasters, just showing you how you can, this is kind of another, I wouldn't say Easter egg, but just a workflow tip. If you want to combine a bunch of files into a single layer, click on the Add Files dialog at the top, click on the raster tab at the top, click the plus button, and I'm just going to do a Control-V. I'm going to input that location where all those tile files are, and then select them, click Open. So now I can re-import, and it's going to put these all on the same layer. I know these are already pyramided, so I can uncheck pyramid, and that'll go a little bit faster. Click Open. And now all those raster files, they're all located on a single layer. If we click on the raster files tab at the bottom left, you can see all of them loaded on a single layer. And we can do things like what we were doing before, turn them on and off here for the display. But I just want to show you, this is a really neat trick. If you get a tiled ortho from someone else, you're seeing this difference in color balance. I'm going to right click on the raster 4 layer where I brought all these in, go to properties at the bottom, and then disable the enable linear % clip option. Disable that and click OK, and see it balances out and all the color balance for the tile files. So you can look at that, all together like that. Let me go and zoom in. Of course, remember, we still have that pixel gap I talked about, but this is just a way you can tile the orthos to be used in different CAD packages. Hopefully, everybody that was trying to follow along was able to follow. And then we're going to go to our last section here, LandXML export. So this is part D on page 51. To start with, I think we were hesitant to add this format as an export for a number of years just because of the limitations of it. But it's just so many customers are totally dependent on this format. They need this export, but you're just really limited in the size that you can export before things just start to fall apart. So you're not going to be able to create a LandXML with a really, hyper dense data set. I'm going to click on the live view filter here at the top, and then I'm just going to do a quick scan of the data. Just making sure this is still going. We've got, I don't know, this is well over 100 million points, maybe 150 million points. There's no way you're going to make a LandXML file based on all these points. Even just the ground points, which is typically what you would do, there's no way you're going to be able to do 50 million points there. So what we need to do first is thin the data so we can we can reduce it to an appropriate amount so we can actually make a LandXML file. So I'm going to turn off my raster layer. Let's just look at just the LAS data. Click on the point task at the top, and in your PCT group that I gave you, click on the ground thinning option and click on the active PCT settings. And basically I'm choosing a cell size of 1 foot, and I'm basically making a 10 points per square foot thinning here. And my destination class in this instance, I have it set to withheld. I mean, typically you would use model key points for that, but I'll go ahead and switch to that. Click OK. Click OK here. And let's see where I had you run this. And let's go ahead and run that for the project. So I have my LAS data set to read only. So if you see this, don't panic. Click OK. Click on the LAS files tab at the bottom. See how all the LAS files have this little red lock icon on them. If you double click on that, actually, I'm just going to right click on the layer at the top here and open up all files for read write. It's just telling me, hey, you're opening these up for read write. You're making changes to the files. Just make sure you're okay with that. Click OK. But if you do double click on the individual tiles or individual files, you can, the lock button, you can unlock them and lock them that way. Also, there's this little cylinder icon to the left of that. If you double click on that, that turns those individual files on and off as well for display. Okay, so let's run this by active layer. This should go pretty quick. And then after we run this, we're just going to look in at LAS file analyst to see how many points were thinned, how many points are put into the model key points flag. So click OK. Go to project in the top left. Click on LAS file analyst here. I'm going to do a left click on the row, do a Control A, hit scan. And then I'm going to just scroll over to the right until I get to my different classification rows. And there's section for flags. And there's my model key points. So I've really thinned the data substantially from where it started off. So gone from 50 million points, actually gone from a good bit more than that. Let me just double check my PCT setting here. Yes, I input points and ground. So I've gone from 50 million points to roughly 10 million points. So that'll help us when we generate that LandXML file. We just see here. So let's go ahead and what we're going to do just to make this easier on us, let's go ahead and export a subset file just to make sure that we have a low enough number of points to where we don't have any issues with this export. So go to project at the top, click export wizard, select for export types, points, and export format LAS, input points filter, change that to double click in here in the ground row, click on model key point set. If I'm going too fast for people, let me know. I'm going to click OK here. All right, so we have that set. So I'm going to click OK, hit next, and I'm just going to draw, let's draw, again, like we've been doing, I'm going to do a little draw window. I'm going to draw a little a section over here around the little wall, the little loading dock over there. Click next. I actually hit back. Let's see. Yep, that should be fine. All those settings should be okay, and then just select a place to put that LAS file. I'm just going to call this LAS MKP. Save. Finish. And I have it set to go to the job manager, so it's going to go there. Should go extremely quick. It's just a small little subset that we're doing. Okay, it's already done. I'll hit complete job. Yes. And this should have my little subset. Let me look and see where I exported that. I forgot to hit insert outputs to maps, but I can easily just navigate to that spot. I'm going to click on the add files dialog at the top. Go ahead and navigate to the spot where I made it. You can see I've just made a 30 megabyte file from this data set's actually much, much larger. Okay, there's our little subset there. So last year when we did this, we didn't have the ability to reference breaklines for doing this export LandXML file. So I'm going to go ahead and click on that. And let me turn on my wall breaklines so you can see that in the area for the export. Click on export LandXML at the top. Input points filter. It doesn't matter if we're referencing this file, this LAS layer 2 that I just made, because we've already done the thinning. But let's say you were referencing your original point cloud and you had done your thinning, you would click on the input points filter and then choose, your ground classification, maybe model key points you'd hit set here. So you would do something like that. I've already done all that in the file export that I've done. So I'm going to hit cancel there. So I don't really need to do an input points filter for that. And then I'm going to turn on breakline enforcement for that wall. Use breakline enforcement. I'm going to choose the wall. And, again, typically when you're running this, you would choose your buffer class here. I don't really have a buffer class. I haven't included that. You can see there's no data around the wall. So I don't have to choose that for this scenario. But the one thing we do need to choose is use breakline enforcement. Click on the wall, click OK, and then we'll set our output location. You can set the maximum number of points here. Once you start getting above 1 million points, things start to go really slowly, and you could have some issues with the file. So just keep that in mind. LandXML file just doesn't blow up very well size-wise. So I'm going to just choose a file name. I'll just call it LandXML export. Click save, and then click OK, and this will run. This should go really quick because I made a little subset data set here. Oh, had a crash. LandXML export.
what version are you on? Is I'm not seeing that breadline export option, and still I'm not.
I'm on 210. I can go ahead and enable that experimental build for you after the session, and you can get on it. But the latest one that these guys are running, I think, is 202. So let me go ahead and reopen that project. Okay. Let's do this one more time. I'm going to make an even smaller subset just to ensure that this works okay. So you guys don't have to follow along with this. I'm going to do this just even tinier just so we don't encounter any issues. And the format just really blows up if the file's too big. So you really have to thin it quite a bit. And the break lines really supplement the surface that you're making. So I'm going to go ahead and do this again. I'll go ahead and make the draw window. I'll make it even smaller area that we're looking at. Maybe something like that. You just call it LAS MKP 2. Save, finish. That's going to go really quick. So I'm looking at an even smaller area here. Let's run this again. Let's see. So I'm going to go through the settings again. Turn my break line on. I'll turn on perform on the fly topology corrections. I'll set an output location. Just call it LandXML 2. Save. Hit OK. See if it does any better. Oh, I referenced the LAS layer 2, so it's probably going to break in the same way. Let's see. Nope, produced just fine. So after the export's done, it tells you the number of points. So with this tiny, tiny little area in the thin data set, we're already at 837,000 points. So you really have to thin this down quite a bit. Even more so than what I've already done in a typical scenario. And this is the number of faces. So even with this tiny little data set, we're already at well above 1 million faces here. So that's quite a bit. It just blows up really quickly. So at the end of this exercise, I talk about, let's see here. I think I bled into another exercise. Give me 1 second. I reference, so on page 52 at the bottom, I referenced the LandXML viewer application just to see how this was done. Some of you may already have some software to import a LandXML to check this out. But otherwise, I'm going to go ahead and let's look. I'm going to go to that link. This is, I'm opening up a browser, Carlson LandXML viewer. That's what it is. Oops, wrong one. And it's bringing you to landxml.org. That's where you can download the free viewer. So I'm going to go ahead and open that up and look at the LandXML we produced, that file. Just going to go ahead. This is just a free viewer that you can use. And we go to File, Load at LandXML, and we'll go to that file I produce. Click Open. See, that's already from that little tiny LAS file that was actually a lot smaller, we produced a file that's over 160 megs. Click OK. And just the format is just, and people rely on it. It's a useful format for looking at surfaces, but you can see how it just, performance is just not the same as LAS data for sure. You can see how this is spinning and spinning, just trying to load this small little file. I think I made an even tinier file yesterday, so just so you guys aren't waiting forever on this previewer. There we go. I'm going to end task. go to all, go back to the viewer, load LandXML. This is just one I made yesterday. I think it went really fast. Let's see if I can load a file for you guys to look at. There we go. Well, this is another file. This is the file from last year that I made, so you can look. Let me load another one. Let's see. 1 second. I think I was playing with this. This is a lot tinier file. Let's see how this looks. Let's try that file again. I'll just try to be a little bit more patient here. Let's see. Click open. Okay. Just give it a second. But that's kind of the basics. We kind of went over making that digital elevation model, referencing the break lines, how we can kind of manipulate orthos to better import that into CAD software. Is there anything else you guys want to see or have questions about before we?
Question.
Yeah.
So on ground fitting, what specs are we with that we're trying to nail that 8 plates per square meter?
Okay, that's a very good question. So if you're trying to get to 8 points per square meter, so I'm going to go to the point task, go to active PCT settings for the thinning task. And so you would set units to feet, you set feet or meters. Meters, so you would set the units to meters here at the top, cell size of 1, and then put in 8 there, and then you're good. And so you can check this. So if you go to classification here at the top, this is kind of an Easter egg too. Go to outliers, select, I'm going to select our LAS layer. I'll select LAS layer 2 because it's already, I know it's already a thin data set. Click estimate point density. You can kind of see what the point density is. You see we're still at 83 points per square meter there. But if we ran this, let's run this on this small little data set real quick. Let's make the destination class. This really isn't applicable, but it's synthetic. We'll just choose all points.
Now, also, do you have medians and random selected? How does
you can just do random if you want. So I'll just do random. I won't do median. I won't do minimum because it'll add at least 1 point that's minimum or median, whatever point you do. Then the other ones will be random. But let's just do random. Click OK here, and then we'll run on our LAS layer 2, which is a small little data set. Okay. And then I'll go back to our classification tab at the top, click outliers, go to LAS layer 2, input points filter. I'll filter by synthetic points, what we just did. Click OK, click OK. And now let's estimate the point density. Oh, looks like that filter is not working right. This should have done it. Unless I'm looking at the wrong thing. All right, let's go a step further here. Let's do, let's go to export wizard. Let's export based on that. Wait a second. Let me see something. Let's look. I might have messed something up in the settings. No, that should have been right. Yeah. Should be okay. Just do a quick export.
Did you run the setting on the MKP LS layer.
No, I think it was on LAS layer 2. It should have been, because that was my active LAS layer. This should be right. So one of the things I'm doing here is I did a Control A, and if you want to set a flag for all the points, I'll just set it to synthetic here. Click OK. Next. Next, I'm just going to do basic extent. Next. And just export based on that, so we'll just call it synthetic. Save. Finish. Maybe you're right, maybe I was selecting the wrong thing. But regardless, let's see. Let's go to classification, outliers. There's my synthetic. Oh. Well, it's, wait a second. Huh. I don't know. Should have been, oh, I had set to fee. That's where I messed up. Yep. Yep. So let's have this set to meters. I can even use a different flag this time. Let's do that. Let's do that small little data set just to save us time. That's why. And let's click OK here. Let's run the read write's not on. So we'll double click on that. Little lock button, run that. Went really quick. Let's see if this works. Outliers. Was that the choose withheld, right? Let's see if that does it. Huh. Got us closer.
The idea.
But I've seen that be quite accurate, so that can be a way you can just kind of sanity check yourself to see what the point density is. Just kind of a little Easter egg.
Thank you for showing that.
Yeah.
That's actually very helpful.
But assuming that you make a LandXML file that is reasonably sized, see, it's just a bloated format, so you can view what you made in that viewer. So we just glanced at one I made last year with the LandXML. Any questions or concerns, guys, with anything? Anybody have anything? All right. Well, thanks for attending. Hopefully that was illuminating. So thanks for attending the conference.